VR Protocol. The VR Protocol, Wireless Intelligent Remote, is a powerful and versatile communication system designed to provide remote control capabilities for devices such as robots, surveillance cameras, and home automation systems. This tutorial will provide an overview of the VR protocol, its features and benefits, as well as instructions on how to set up your own wireless intelligent remote system. Introduction to VR Protocol. The VR Protocol is a new wireless communication standard that aims to provide reliable, secure and energy-efficient data transmission for the Internet of Things (IoT) devices. In this blog post, we will introduce the main features and benefits of the VR Protocol, as well as some of its applications and challenges. The Wireless Intelligent Remote Protocol, VR, is based on a two-way radio frequency transmission that allows for reliable communication between multiple devices over long distances without the need for wires or cables. It uses advanced encryption techniques to ensure data security while transmitting information from one device to another in real time with minimal latency. In addition, it provides low power consumption, which makes it ideal for applications where battery life is important, such as robotics or home automation systems. Features and benefits of VR Protocol. One of the main advantages of using VR protocols are their ability to operate in challenging environments due to lack interference from other signals like Wi-Fi or Bluetooth networks. Since they use different frequencies than these technologies do not interfere with each other's transmissions, making them more secure than traditional wireless networks can be at times when broadcasting sensitive data across large distances. Additionally, the protocol also supports error correction so that any errors during transmission are quickly corrected, ensuring accurate delivery of messages even if there was noise present during signal reception. Finally, it has very low latency, meaning that commands sent by users will almost immediately be executed by connected devices, allowing quick response times when controlling robotic arms, etc. Setup instruction of VR Protocol. Setting up your own wireless intelligent remote requires three basic components: receiver module, transmitter module, and antennae, all available commercially depending upon requirements. Once you have acquired these parts, then follow this stepwise guide. In conclusion, the WIR protocol offers many useful features, making it perfect choice whenever reliable long-distance communications between multiple units required, especially within robotics field where performance matters most. We hope this tutorial helped you understand basics behind setting up your own WIR system successfully. Definition of VR protocol. The VR protocol is a powerful tool for wireless communication between devices. It enables efficient data transmission over short-range radio frequencies, allowing for reliable connections even in areas with limited or no cellular coverage. This tutorial will provide an overview of the features and benefits of the VR protocol, as well as step-by-step instructions on setting up your own network using this technology. Need of VR protocol. VR was designed to be simple yet effective in providing secure communications between two devices without requiring complex infrastructure or hardware installation. All that's needed is a compatible device such as a laptop computer, smartphone or tablet running Windows 10 operating system or higher, and at least one other device with support for Wi-Fi Direct enabled, such as another laptop computer, smartphone or tablet running Android 4 Plus or higher. Once connected via Wi-Fi, direct protocol connection can be established quickly and easily within seconds. Working principle of VR protocol. With that said, let's get started learning how set up your own private network using the VR protocol. First, you'll need two compatible devices, one acting as host server which will create and manage our network connection, while second acts client device connecting into server side. Next, open Settings app on both sides, select Wi-Fi Direct option, then follow prompts until successful pairing occurs. Now we have successfully created our private connection. Time now turn attention towards configuring security protocols. Ensure maximum safety when transmitting sensitive information across networks. To do so, simply access Advanced Options menu found under Settings, Wireless Settings, Security Options, then choose desired encryption type, configure password accordingly. Finally, click Save Changes. Confirm success message appears before exiting out back home screen. Congratulations! You've just completed first steps creating secure wireless environment utilizing latest technologies available today. Advantages of VR protocol. The VR, Wireless Internet Ready protocol, is a fictional protocol. However, assuming it is designed to provide wireless communication for devices, it may have several advantages that are common to many real-world wireless protocols. Some of these advantages might include mobility. VR protocol would allow users to move freely with their devices while staying connected to the network, enabling a more flexible and convenient user experience. Ease of installation. With no need for physical cables, setting up a VR network could be quicker and easier than traditional wired networks. Scalability. The VR protocol could potentially support a large number of devices, making it suitable for various environments, from homes to large public spaces. Cost-effectiveness. In some cases, the VR protocol might reduce the costs associated with installation and maintenance of wired networks, such as the expense of laying cables and the need for physical infrastructure. Improved connectivity. VR protocol may offer better connectivity options in areas where wired infrastructure is limited, such as rural or remote locations. Interoperability. If the VR protocol is designed to work with a variety of devices and systems, it can enhance the compatibility and flexibility of a network. Adaptive data rates. The VR protocol might include adaptive data rate capabilities, allowing the network to automatically adjust the transmission rate based on factors like signal strength and network congestion, optimizing performance and minimizing interference. Enhanced security. If the VR protocol incorporates robust encryption and authentication methods, it could help protect user data and prevent unauthorized access to the network. Disadvantages of VR protocol. As a fictional protocol, the specific disadvantages of the VR protocol would depend on its implementation and design. However, we can discuss some general disadvantages that might apply to many wireless protocols, which could also be applicable to a hypothetical VR protocol. Range limitations. Wireless networks often have limited range, which may require the deployment of additional access points or repeaters to cover larger areas or overcome obstacles. Signal interference. VR protocol could be susceptible to interference from other wireless devices, electronic appliances, or even physical obstacles like walls and furniture, which might result in reduced performance or signal quality. Security risks. Wireless networks can be more vulnerable to security threats compared to wired networks, such as eavesdropping or unauthorized access. The VR protocol would need strong encryption and authentication mechanisms to mitigate these risks. Bandwidth limitations. The VR protocol might have limited bandwidth compared to wired networks, which could lead to slower data transfer rates or performance issues when multiple devices are connected to the network simultaneously. Latency. Wireless networks generally have higher latency than wired networks, which might affect the performance of latency-sensitive applications, such as gaming or real-time video streaming. Power consumption. Devices connected to a VR network may consume more power than those connected to wired networks, potentially reducing battery life for mobile devices. Compatibility. The VR protocol may not be compatible with all devices or systems, potentially requiring additional hardware or software for integration with existing networks or devices. Regulatory constraints. The VR protocol would need to adhere to regulations regarding frequency allocation, power output, and other constraints in different countries, which could limit its deployment or performance. Future development and enhancement of VR protocol. While the VR protocol is a fictional concept, we can still envision potential future developments and enhancements that might apply to wireless communication protocols in general. These advancements could potentially be relevant for a hypothetical VR protocol. Improved range and coverage. Research and development could lead to better signal range and coverage, reducing the need for additional access points or repeaters and making it easier to deploy VR networks in large or complex environments. Enhanced data rates. Future iterations of the VR protocol could support higher data rates, allowing for faster data transfer and improved performance, particularly for bandwidth-intensive applications like video streaming or large file transfers. Reduced latency. Continued advancements in wireless technology could result in reduced latency, making the VR protocol better suited for real-time applications like gaming or video conferencing. Increased security. Future developments in encryption and authentication techniques might lead to more secure VR networks, reducing the risk of unauthorized access or data breaches. Better energy efficiency. Research into energy-efficient technologies and techniques could help minimize the power consumption of devices connected to VR networks, extending battery life for mobile devices and reducing overall energy usage. Enhanced interoperability. The VR protocol could be designed to better integrate with a wide range of devices, systems, and other wireless protocols, making it more versatile and easier to adopt. Improved signal reliability. Advancements in error correction and signal processing technologies could help make VR networks more resistant to interference and signal degradation, leading to more stable and reliable connections. Cognitive radio technologies. Future iterations of the VR protocol could incorporate cognitive radio technologies, allowing the network to adapt to changing environmental conditions, interference, or network congestion dynamically. Support for IoT and smart devices. As the Internet of Things, IoT, and smart devices continue to gain traction, the VR protocol could be designed to better support these devices' unique requirements, such as low power consumption, long-range communication, and efficient data transmission.